Okay, so let's have a go at proving this exercise here. Precondition states I is greater than or equal to j and j is strictly greater than 0. The code we're executing is replace I with I plus j, and the postcondition states I is strictly greater than j. We want to prove this to be true using Hall logic, and we're going to do it two ways. We're going to do it using assignment rule forwards, and we're going to do it another way using assignment rule backwards, so that we can see the two different proof techniques. Which one is easier? It actually depends on the problem. Sometimes forwards easier, sometimes backwards easier. So we'll do both and we'll see what happens. So I'll do forwards first. So I'll sort of cut this in half, and I'll put my goal at the bottom. So I is greater than or equal to j, and j is strictly greater than 0. Replace I with I plus j, and then I is strictly greater than j. So what I'm going to do is I'm going to copy up the precondition and then attempt to do the assignment rule forwards. Okay, so here's the code. Okay, so let's look what the code does. Replace all I plus j's in here with i's. That's no good. There are no I plus j's to replace. If we did this code, it would do nothing. We'd get the same post condition and we wouldn't really be able to get anywhere. Okay, so that's no good. What could we do instead? Well, we could try and modify the precondition to something that's equivalent but has an I plus j term in it. So if I added j to both sides of this equation, it would still be true, but now there would be an I plus j term present. So let's try doing that. So instead I will write I plus j is greater than or equal to 2j, and j is strictly greater than 0. Replace I with I plus j, and then what's my postcondition going to be? So let's see. Let's look at how the assignment rule works. Replace the e's with the x's. So replace the I plus j's with the i's. So we're going to get I is greater than or equal to 2j, and j is strictly greater than 0 by the assignment rule. Okay, cool. So now I'm going to work out how to get from here down to here. The code is the same, but the preconditions are different and the postconditions are different. Well, we know the preconditions, while they look different, they're logically equivalent because we rigged this to be the same as that, right? That was what we did to make that valid. So I plus j greater than or equal to 2j, and j strictly greater than 0 is logically equivalent to this statement here. And j greater than 0 by logic. So I can just hot swap them back out afterwards, right? So then we get I is greater than or equal to j, and j is greater than 0, and then the code, and then this post condition here. I greater than or equal to 2j, and j greater than 0. So how do we do that? That was a precondition equivalence, lines 1 and 2, and I guess I should label my lines. I'm sort of squishing things in here. So this is line 1, this is line 2, this is line 3. Okay, so now I need to get from here down to here. And the only way I can change the post condition is by using the post condition weakening rule. So it had better be the case this thing is stronger than this thing here, or if you prefer, this post condition implies this post condition. So let's write that out. I is greater than or equal to 2j, and j is strictly greater than 0 implies I is strictly greater than j. Is that true? So what I like to do is I sort of like check my work in the margin, right? So I'll put that aside for a moment, and we'll check if that's valid. I is greater than 2j, and j is strictly greater than 0 implies I is strictly greater than j. Well, if I is greater than or equal to 2j, well, we have that fact. J is positive, so that means 2j is strictly greater than j, and these two facts put together tells me that I is greater than j. So yes, this is indeed a true statement. So we'll put that in, so that's logic. You don't have to include the proof of this in your Hall logic proof, but it's good to convince yourself that this is indeed a valid statement. That's line 4, and then line 5 follows by post-condition weakening. So post-con weak by 3 and 4. Okay? So that was one way to do it, using the assignment rule forwards, and we had to sort of rig the precondition so we could do the assignment rule forwards. Let's try doing it backwards, and hopefully it might be a little bit easier. So once again, I'll write the goal at the bottom. So what do we got? I is greater than or equal to j, and j is strictly greater than 0. Replace I with I plus j, I is strictly greater than j. Okay, so now I'm going to copy up the post condition now. I'm going to write the piece of code, and I'm going to do it backwards. So what would have to live over here, such that if I replaced the I plus j's with i's, I would get this term over here. Well, that's just this term, but I replaced with I plus j. So I plus j is strictly greater than j. And that makes sense, right? Because if we assume this, and I replace all I plus j's with i's, because that's what the assignment rule does, I'll get this over here. So this statement here is valid by Hall logic. So that's the assignment rule. The code is the same. Post condition is the same, but the precondition is different. So it hopefully should be the case the precondition is stronger, because if it's not, we're basically boned. There's nowhere to get from here to there other than using precondition strengthening. So we replace the weak thing with the strong thing. So hopefully this thing is stronger. So if we have I is greater than or equal to j, and j is greater than 0, does that imply I plus j is strictly greater than j? Maybe. Let's try to convince ourselves that that's true. So I've got I is greater than or equal to j, and I've got j is strictly greater than 0. So if I is greater than or equal to j, well, that means one of two things. It means either I is equal to j, or it means I is strictly greater than j. And what I'm doing here is I'm adding j to the left-hand side. So if I add j to the left-hand side of this equation, well, if j is positive and I is bigger than j, if I add j here, that makes it strictly bigger, right? If I make the bigger thing bigger, it's still bigger than j, right? So if I turn this into that, that's definitely still true. And here on the left, if I and j are the same, and I add a strictly positive constant to the left, well, I plus j will definitely be bigger than j, right? Because if I and j are the same, and you add something positive on the left is now bigger. So in either case, these two facts imply I plus j is greater than or equal to j. So yeah, we've convinced ourselves it's true. So I'll put that over there. This is true by logic. And then we can jump immediately to the last line by precondition strengthening. So precon strengthening, lines 1 and 2. So it looks like in this particular question, it was easier to do assignment rule backwards rather than assignment rule forwards. But that's not always going to be the case. Sometimes it's easier to do assignment rule forwards. It's kind of hard to gauge which one you should use. I mean, sometimes if you try to do it forwards or if you try to do it backwards, it doesn't even work. So, I mean, worst case, just try both and hopefully one of them will work. But you can see in some cases, you could do it either way. Both of these proofs are equally valid. They both give you full marks. I guess I prefer this one because it's shorter, but they're both totally valid. And we don't ask for an optimal proof, just any proof that works.